Yes, okay. You can start.
Okay, thank you so much. Hello, everyone. Good afternoon. My name is Julie. Very nice to meeting you. I'm very happy to representing our founder, Boyi Wan, to presenting here and to share with you our company's R&D breakthrough and practical achievement in carbon anode anti-oxidation coating technology, a solution tailor-made to address most pressing pain point plaguing modern aluminum metallurgy industry. So for the next 30 minutes, I will walk you through our corporate version in the industry challenges-driven innovation and the core of our nano-ceramic-based coating technology, rigorous test result across global smelters, and the tangible economic environment benefit it brings. And so now let's dive deep into this technology that redefining energy saving and consumption reduction in aluminum production. So first, a brief introduction of our company. So our company's name is Hunan Babel Material Technology, and we're established in January 2017, so almost 9 years. Next year will be 10 years, and was located in Hunan provinces, which is the chairman Mao and our president of New China, chairman of New China, and we're quite proud of our hometown. And we are adhering to the development of concept of low carbon environmental protection, innovation, service, and the mission of creating excellent energy saving product and service for the metallurgical enterprises. So we always encourage ourselves to be an expert in energy saving and consumption reduction. And we continuously researches and develops new materials and new technology for this area, especially for non-ferrous metallurgical energy saving industry. And our entire R&D and production system is focused on new materials. So after years of in-depth research and field tests and continuous optimization, we have launched nano-ceramic-based anti-oxidation anode coating technology. That's what we're going to discuss today. And that has been verified in over 20 smelters in China and Malaysia and India, and has delivered remarkable results for aluminum producers. So let's talk about urgent industry needs that pushes us to do this in technology. So let's turn to the next page. For anyone who works in this industry, we all know carbon anodes are the heart of electrolytic pots. The quality of anodes directly determines the stability of product, the efficiency, and even the final quality of aluminum products. So in the recent years, the industry has been facing a double squeeze. So on one hand, the supply of high quality calcined coke is shrinking rapidly, and the price is rising steadily. On the other hand, enterprises are under unprecedented pressure to cut production costs and improve optional efficiency. So cope with this, most smelters has to, turn to high sulfur or high vanadium coke as alternatives. While this reduces the raw material cost in the short term, and it brings a disaster problem. So poor anode quality, drastically reduced oxidation resistance, massive carbon residues generated in the electrolyte, and severe damage to the pot. So we all know the consequences. So when the carbon residues increase in the bath resistance, which will lead to instability in the operation. When frequent anode oxidation forces more frequent anode replacement, which not only increases raw material consumption, but will also cause additional voltage interference and production interruptions. So the quality of the aluminum product is also will be affected. So for the long term, the whole industry solution was to use high quality anode and implement extremely meticulous process management. But manpower in this industry also is a big challenge. We actually recently visit many smelters globally. After survey, they all tell us it's really hard to find somebody who, especially young generation, young manpower, who would like to work in the manpower. So this is no longer feasible under the current resource and the cost constraints. So the entire industry is crying out for a new technology, one that can improve the oxidation resistance of carbon anodes made from ordinary raw materials, reduce carbon residues, stabilize pot operation, cut the energy and material consumption. So this is exactly the problem that our Babel, our anti-oxidation coating technology is designed to solve. So our anode coating technology has been tested in China for years, and our solution stands out for its room temperature solidification. So this is important, like a room temperature solidification and high temperature resistance and long-term stability, and make it quite practical. This is important, and scalable solutions for global smelters. And next, let's get into the core of our technology. We'll go to the next page. Our nanoceramic based anti-oxidation anode coating, and what makes it so special. As the most basic, our technology is about applying a specialized coating to the surface of carbon, the anode, but its magic lies in its unique properties and the scientific reaction process it undergoes during the aluminum production. Let me break you down step by step so you will understand how does it work. So first is the key property of the coating itself, and the game changing. It's unlike the traditional coating that requires high temperature curing or have poor adhesion. Our coating has outstanding advantage of room temperature solidification, which means that it can be applied directly in a smelter workshops without additional curing equipment. Usually when you spray it after 4 hours dry, normal temperature, 4 hours, you can directly put into the pot. But if you spray it in a very extremely cold temperature, such as Norway, minus 15 degree, maybe wait for 12 hours and dry, and then you can put into the pot directly. And we already did test in the northeast part of China. And so this means that our product can apply directly in smelter workshops without additional curing equipment. This can save both time and investment. It also quick drying, it's non-toxic, it's non-sticky, no harmful, and no harmful substances are released during the application or use, applying with global environment and safety standard. And also it's washable. Some customer ask us if we want to wash off the coating. They said, okay, yes, you can use water to wash it off. It won't stick to electrolyte and other components, ensure smooth pot operation. So most importantly, it boasts excellent high temperature resistance, anti-corrosion performance, high hardness, and strong adhesion. All the critical properties a coating needs to survive a harsh, high temperature environment of electrolytic pot, above 900 degrees, and corrosion of hydrogen fluoride gas, high concentration CO2 and air. And then we're gonna talk about the reaction process of the spraying. When our nano-ceramic-based coating is spraying on the anode surface, a fascinating physical and chemical change happens as the anode temperature rises. The grains of the coating material shrinks gradually, and the crystal gas become smaller and smaller. And when the temperature reaches like around 400 degrees to 500 degrees, it will center. And when the temperature reached that 400 degrees, the coating completes pre-centered and high-strength, dense network structured center body forms a protective layer around carbon anodes, like our armor, like a hard armor, a custom made for the anode. This armor is incredibly durable. It can withstand high temperature above 100 degrees for a long time. It acts like a impenetrable barrier between the carbon anode and the oxidizing substance in the pot. So including air, hydrogen, fluoride gas, and high concentration CO2. So by blocking this contact, the coating fundamentally prevent anode oxidation and carbon loss. So this is the core principle behind our technology that makes it effective and helps it to solve the pain point. So to achieve the extraordinary performance, the composition of the coating is something people always ask us, what's the composition of our coating? And every component has specific role, and I would like to share with you right now. And we work each component. I want to say each component, they work together to create a perfect protective layer. And let's go to the next page. You can see 45 to 50% of our component actually is aluminum. Is alumina. That's the backbone of our coating. It provides high hardness, high temperature resistance, and structural stability, and forming the basic framework of the center body. And here, I want to emphasize comprehensive considerations were made in the initial designing. On one hand, it can the alumina, it can effectively protect the carbon block and achieve energy conservation and consumption reduction. On the other hand, it can safely dissolve together with the molten electrolyte and participating in system circulation. Because we know many smelters, they will recycle the butt without damaging the original works and conditions of the electrolyte cell, polluting the electrolyte or affecting the quality of primary aluminum and electrolysis efficiency. So which make it highly compatible with the entire electrolytic production system. So since the very beginning, we take everything into our consideration. And also we have alkali matter grain boundary fusion components, 2 to 3%, and silicon SOL. You can see here. Well, what I want to say, every percentage, every component is the result of our R&D team's countless tests and optimism. We didn't just mix materials. Some people just ask us, well, you just need to purchasing those materials and you mix them up. No, it's not like this. We engineered a coating and that is perfectly adapted to harsh environment of aluminum electrolysis, and we indirectly use our special equipment to handle it. That's our special techniques and is our pattern. Yeah. And let's turn to the next page. the test result. I think that's the most important part of today's presentation, the test result and practical performance of our technology. And because we all believe, good technology, you have to have great performance. It should not be just a good theory. And that's why we have conduct a rigorous long-term test of our nano-ceramic based coating in over 20 smelters across China and Malaysia and India, with potline covering 240 to 500 Ka. But the mainstream amperage in industry is like a 240 to 500 Ka, yeah, ranging from 64 Ka to 530 Ka, but mainly is from 240 to 500 Ka, and adapted to two different types of bath system, pure bath system and complex bath system. So this wide range of tests ensure that our technology is not just effective in a lab or a single smelter, is scalable and adaptable to different production conditions around the world. And for key verification tests, we selected our 400 Ka potline and conducted our 12 months continuous test. That means a full year of real production conditions, no lab simulations. We divided 6 sections of potline into 2 groups, 3 sections with, our coating applied on anode, on carbon anodes, and the other 3 sections uncoated for a direct side-by-side comparison. So all other production parameters were kept exactly the same. This way, any difference can be directly attributed to our coating. So after a year, after 12 months continuous data collection analysis, the results were truly remarkable. Our coating brought positive improvement to all key production indicators, as you can see from this form. And the benefits were tangible and measurable. Let's go through these improvements one by one and with real data. And let's turn to the first page. Well, you can see here we can see the current consumption, the noisy, the GCC, primary aluminum. Oh, we can go to the first and next page. We can go to the next page as that's the noise, yes. So dramatic improvement in pot stability and significant reduction in noise level, because we all know that pot stability is the foundation of efficient aluminum production. And unstable pot leads to frequent production interruptions. So increased energy consumption, poor production quality. And our coating changes this by reducing the carbon contents in the buff and lower the buff resistance. So two key factors that cause pot instability. So with less carbon residue and less resistance, the effective anode cathode distance is increased and the pot runs much more smoothly and stably. As a direct result, the noise level of the potline we can see drop significantly. So for smelters, this means a more stable production environment and less wear and tear on the pot equipment, extending the service life of extensive electrolyte pot assets. Okay, so let's turn to the next page. This is about the influence of power consumption. Because power consumption is also another biggest cost drivers for aluminum smelters. Every kWh saved translate directly to higher profit. Our coating reduces power consumption in two key ways, which creating a double reduction effect. On one hand, the protective center body reduces anode surface oxidation, and carbon reduces in the buff, which directly decreases buff resistance and cut power consumption for electrolysis. On the other hand, coating prolongs the anode change cycle and reduces the number of anode change operations. So fewer anode changes means less interfere to the pot operation, less additional voltage caused by replacement, less further cut power consumption. So for smelters, this dual reduction means less electricity bill, a smelter carbon footprint, a better compliance with global energy saving, and emission reduction regulations. So this is remarkable. Well, let's turn to the next page. I'm gonna sharing with you the current efficiency. That's also the key indicator of how effective a smelter converts electricity to aluminum. Because even a tiny increase in current efficiency can bring huge economy benefit. Actually, this is what Chinese smelters care so much. And our coating improves current efficiency in a scientific way. How? How can we do that? By reducing anode oxidation. The anode shape remains much more regular with the coating protection, and the anode current density is lowered. Under the same voltage condition, the increased effective anode cathode distance allows the electric current to be used more efficiently rather than being wasted on resistance or side reduction. The test results show a clear and consistent increase in current efficiency for the coated sections. This means smelters can produce more aluminum with the same amount of electricity, directly boosting production efficiency and output. And this is quite beneficial for those smelters in Middle East. And let's turn to the next page. The fourth, the significant reduction in gross annual consumption. So we say GCC. Annual consumption is another major raw material cost for smelters. And our coating delivers one of these most impressive benefits here, a drastic reduction in gross annual consumption. How does it happen? The high strength, dense network structure center body acts as a perfect barrier, like an armor, isolating the carbon anodes from air and CO2 in the pot. This isolation avoids two key reactions that cause carbon loss: the redox reaction between the anodes and oxidizing gas, and the bondwards reaction between the anodes and the CO2. By stopping this reaction at the source, and coating fundamentally reduces the anode wear and tear, meaning each anode lasts much longer, less carbon, and this is the huge cost saver for smelters, especially in an environment where carbon anode raw material are getting more expensive. Turn to the next page, please. So the influence on silicon and iron. Well, because this will directly influence the quality of aluminum. The product quality is the lifeblood of the aluminum producer, and their coating also bring tangible improvement to the quality of final aluminum product, specifically by the reducing of the silicon and iron impurity contents. And because the protective layer of the coating makes the consumption of anode butt much less than before, and much less in terms of the height, the length, the width, the thickness. This means the anode bud remains thicker during the production. Its ability to resist scratching, melting, the bottom penetration is greatly enhanced, and fewer anode fragments fell into the electrolyte, and less silicon, less iron impurity are introduced to the aluminum product. Of course, the aluminum quality is more guaranteed. And also, what's more, the coating extends the anode changing cycle by one more day. And this is also what Chinese smelters care so much. They ask for extend one more day of the anode. And these, like also the high quality aluminum product, better market competitive, and the ability to meet stricter product quality standards for higher end aluminum applications. So yeah, let's turn to the next page. This is about anode stop, anode stick club. Yeah. The effective protection of anode stop and extended service life. So the anode stop are critical components of electrolytic pot, and their corrosion is our major maintenance cost for smelter. And our coating doesn't just protect the carbon anode, it also protects the stop connected to the anode. And the test data on corrosion resistance is truly eye-open. After full pre-baked anode replacement cycle, the difference between coated and uncoated is striking. According to our observation, and the coated stop surface is gray and smooth with no oxidation caking, while the uncoated stop surface is black and rough with severe oxidation and with more narrow neck phenomenon. And uncoated stop diameter corrosion rate of 8 mm per cycle, while coated stop diameter corrosion rate of just 2.42 mm per cycle. That is, 70% reduction in corrosion rate for the coated stops. So this means that anode stop lasts much longer, reducing the need for frequent replacement. That saves a lot of manpower and saves a lot of, that means much more better maintenance. For smelters, this translates to lower maintenance cost, less production, and for components replacement, and extended service lifetime. That's for the anode. Okay, let's go to the next page. Okay, well, let's come to the conclusion. So we are very confident with our product. After analyzing all these test results, all those practical data and on-site performance, we have drawn very clear and actionable conclusion about our nano ceramic based anti-oxidation nano anode coating technology by 12 months of real production test of 20 smelters. First is anode changing schedule extension. When the anti-oxidation performance of coating is less than 1.5%, the technology can extend the anode change cycle by 1 full day, a huge improvement for smelter production, scheduling, and efficiency. This is the first one we want to emphasize. And secondly, our comprehensive improvement of production indicators. The application of our coating has a positive and measurable effect on every key production indicator, reducing noise level, power consumption, cutting gross annual consumption, improving current efficiency, enhancing the quality of aluminum products, lower silicon, low iron components. There is no trade-off. All indicators move in the right direction. And number 3, tangible economic and environmental benefits. Our technology delivers concrete, quantifiable profit for smelters. And here is also some tangible benefit that the gross annual consumption could be reduced by 15 to 25 kg per CTL, directly cutting raw material cost, and increase service life of anodes by 50 to 70%, slashing maintenance and replacement costs for steel cloths, and reduce energy consumption by 20 to 50 kWh per TL, lower electricity bill and reducing carbon emissions, and cut annual CO2 emissions. And all this benefit add up to significant economic gains for smelters. And our technology can be tailored to meet specific production needs and deliver a fast return on investment. So before I wrap up, I'd like to briefly mention the global application scope of our technology. As you can see from our test and application list, our coating has been verified in smelters across China, like Gansu, like Guangxi, Pingou Smelter, Guizhou, Inner Mongolia, Pingou Smelter, Shandong Weiqiao, Shanxi Ferrous, Malaysia, Poca, India. Anyway, covering different regions, different potlines, different bus systems, different amperages. That proves that the technology is not limited by regional, not limited by production conditions, not limited by the temperature, not limited by the climate. It's a scalable global solution for all the aluminum industry. And we have professional technical team and service team like Uni7 to support us, providing one-stop service for all the smelters, from one-site coding application guidance to post-application data tracking and optimization. And we work closely with each smelters to tailor our technology to their specific production needs to ensure the best possible result and maximum benefit. So that's our sharing today. Thank you so much. Yeah. And we are very eager to cooperate with smelters, research, and all types of researching institutions and industry partners around the world, and to share our technology, to exchange our experience and create a win-win result in the future together. Thank you. Thank you. Please.
Thank you so much, Julie. Now that our presentation is over, we have arranged a set of questionnaire to address the various challenges or questions regarding the anode oxidation. So I would be reading the questions one by one, and Julie or Mr. Wong can answer them accordingly, right?
Yeah, I will be responsible for translating to Mr. Wong.
Yeah. So the first question goes like, how does this coating chemistry differ from the traditional anti-oxidation solutions in aluminium smelting?
那个博一，现在在问答时间，然后他们想问你第一个问题就是，我们的 bubble 的这个涂层跟传统的这个涂层涂料解决方案有哪些不同？
你就按照那个回答就是了，曼姐。
就是我们肯定要走这个流程，你懂我意思吗？要说一下，
好的。
你大致说一下，然后我来翻译啊。
行。 涂层材料全世界范围内研究了多年。我们是中国，至少我了解的第一家做到产业化推广的，我们是走在最前列的。前面从90年代，上世纪90年代，中国很多这个高校、大学，或者大的企业公司都做过类似的研究，均未得到推广，所以技术难度是非常大的。这最大的难度还不是技术难度，而是产品开发出来。
他问我们跟其他们的产品区别在哪里？第二个问题。
对，所以我们是第一家做到产业化推广的，是走在最前列的，所以前面的方案都没有上市就被淘汰了，所以我们就是做在最前面的。
Okay, our coating material has been researched worldwide for many years. Actually, we're the first company in China to achieve industrialization and commercialization. And as you can see, our company has been organized for 9 years already. We're the forefront. Earlier solutions are eliminated before they were launched. So we don't really have detailed knowledge about what's their formula, have no idea.
Okay, so we get that.
Fair
What
enough.
are the
Fair enough. Fair enough. Just to add what Ms. Julie says, and as we understand, Mr. Bowie, as we are the partner for the application for and coating. This material is different because of some certain material which Mr. Bowie has developed over 8 years of research and development in Babel. So those are some patented material which is added to this product, which differs the performance of this specific material in compared with the conventional processes. It is the result of this R&D process, and that's the patented material property that Mr. Boyang Boy has developed. So we cannot disclose all those chemical compositions, but this is the material which differs our product than the traditional products here.
Thank you so much, Mr. Shomudi Ghosh. So I'm proceeding with the second question. What are the biggest challenges you have faced while developing this coating technology?
就是接下来就那个第三个问题，就是你在整个研发当中真正遇到的挑战是什么？
那我讲一下吧。
就讲好像对，
这个第三个问题嘛，这个类似于阳极涂层材料，据我了解，上世纪70年代，美女公司就在做过类似的尝试。中国是上世纪90年代在做尝试的，也就是我们有很多的科研机构、高校、大专院所都做过类似的尝试，都希望开发出一种涂层材料，达到一个我们相应的目的。
As far as Mr. Wang know that Alcohol, very famous company, they also start their R&D on coating since 1970s and on coating researching. And there are also a lot of universities and institutes in China try to researching on coating. 继续。
Okay.
He still want to say something.
所以我们整个几十年的这种研发经历，说明了这个涂层材料达到我们相应的使用目的，它是有很大的技术难度的。但是就我个人的感受来讲，它的技术难度抛开一边不讲，真正在中国推广这个技术的难度，而是我们在推出之初，就是我们公司成立之前，我们想推广这个技术，我们很难得到一个好的实验机会。就算电解铝企业给了我们一个小的实验机会，他们也会非常的不重视这种实验。究其原因，就是我们的前人在这方面做过太多的努力，而均以失败告终。 所以整个行业内几乎已经对阳极涂层技术能有足够的效果，能有产业化推广的这种效果，不抱任何希望。那么我们正是在这种环境下面，从一个名不经见经卷的小公司，把无人相信可以做成的技术，给它做到了真正的产业化。那么
Okay, so Mr. Wang tried to say, the whole world thinking coating is the way to work out the problem, to help the anode to save energy, and that's why so many companies or university institutes spend time and energy to do R&D, but there's no good result. That's why smelters, they don't believe there will be a successful coating appeared in the world. So it's very hard for enterprises like Babel when once he started to set up the company to get a chance to into the smelter to do little try on, to have the opportunity to apply their product there. So it's really difficult in the very beginning. And until gradually, little by little, Pinggo Smelter, Shanxinan Ferris, Guangzhou, and Guizhou, little by little, one pot line, another pot line, and until full scale, they see the result. People start to trust you. This is, you have to use data 1 month, another month, and one pot line, another pot line to follow up. This is the most difficult thing. Yeah.
Okay. Julie, we have a question from one of our external. He is asking, what is the coating thickness?
Techniques.
Yeah, thickness.
他想问你这个 coating 你在技术上面用了哪些特殊的技术？
好吧，我就讲几点。第一个就是粉体材料的技术，微纳米粉体材料的技术。我是学化工，专做微纳米粉体材料研发的。在这个里面，我们光是氧化铝就使用了2种，一种只是微米级的，它的粒径在1到2个微米左右，有2个波峰，它这个波峰非常讲究，就是这种力度的波峰非常讲究，这个波峰怎么分布？第二是纳米氧化铝，我们传统讲的力度在100到100多个纳米的，它也是有一个力度分布的。这2种氧化醚如何完成最佳的契合度，或者讲叫配伍度，这是一个非常在微观形貌上面很难实现的一项技术。这是第一点。第二点，如何让这个产品能够在400到420度的时候低温烧结致密化。我们知道氧化铝陶瓷不论是99瓷、95瓷，它的烧结温度都是在1300到1400度，而我们能够借助电解槽的槽温，在400度或者400多度的时候完成这个致密烧结板结的这个过程。那么我们在晶界上面用了一些特殊的处理技术，能降低晶界的熔点和板结的温度。那么降低晶界的板结温度的同时，能够让晶缝、晶孔能够收缩，形成致密的涂层。除此之外，还有微纳米粉体技术专用的层化处理技术。层化静置处理技术。除此之外，还有一项核心技术，我这里就不讲太多了，谢谢。
Julie, you're on mute.
Mr. Wang, his major actually is nano material researching in his profession in the university. So he want to emphasize the nano powder R&D focus, how to achieve centering, densification for bimodal particle size distribution and reduce intercrystalline gasps. Those really need technicals. That's
Double.
his
Julie,
like a
Julie,
double.
I'm just interrupting. The question was not the technique. It was what is the thickness of the coating material upon the anodes. So the answer will be, I'm just giving the answer, that will be 0.8 to 1.2 mm. Okay.
You mean the component?
No, the thickness of the coating. The thickness of the coating, how much? It should be 0.8 to 1.2 mm.
We already show on the PPT actually. For the
Yeah,
component.
Yes, about the component, the details are there in the PPT, and also I would like to add on to Mr. Leonardo, who had dropped down a question. Can you explain more in detail how is the application? We have our PPT does discusses about this. The discussion is in detail. Once this webinar is over, I will be sharing the deck as well as the recording. Post that, if you still have any questions, you can mail us, and we will be glad to answer. Even from Uni 7 as well, the experts can answer the questions about the technology.
Okay.
Right? Yeah. So, Julia, moving on to the next question. Has there been a measurable impact on CO2 emissions or other environmental metrics due to the coating?
王贝就是第四个问题，就说那个二氧化碳那个排放量有没有产生一些可量化的影响？对。
关于这个产品所带来的经济价值和环保价值，我们24年年底做过一次由中国工程院院士邱院士主持的成果鉴定，在这个鉴定结论里面显示，二氧化碳的排放量每吨铝可以降低50千克，每吨铝碳渣电解槽中产生的这种碳渣量可以降低30%以上。
碳渣
，carbon
slagging
30%。carbon slag.
Carbon slag can low down 30%, and coating can reduce carbon emission by approximately 50 kg per ton of aluminum produced. And this is the number according to a very high level academic level achievement appraisal hosted by China Non-Ferrous Metal Industry Association. Yeah, that's the number.
Thank you. The next question is, does the coating change the thermal behavior or heat distribution of the anode during electrolysis?
第5个问题，它改不改变那个热量什么的？
从我们6年来的工业化大面积推广结果来看，6、7年对电解槽的热平衡及电解槽内等温线的分布没有发现影响，而且理论也支持无影响。首先，涂层材料是阳极外表面涂覆，不参与导电，因此没有电阻，不产生这个电阻发热。第二的话，涂层材料碰到电解质之后会溶解进入电解质中，成为它们生产中所需要的原料。所以不支持会产生热平衡方面的影响。
This actually we share in the share before. like based on our 6 years large scale application, our coating has no effect on the thermal balance or optimum distribution, which has also supported by the theory. First, the coating will apply the coating on the outer space of the anode. So the coating does not participate in the electrical conduction, so it does not generate heat. And secondly, the coating material dissolve into the electrolyte once it contact with it. Yeah.
Okay. Julie, I would like to go on to the 7th question of the questionnaire, like how scalable is this coating process across different potline sizes, like 240K versus 500K? How scalable it is with different potline sizes?
他问他这个稳定性跟不一样的这种铅铵的这种槽子，它的这个稳定性是个什么样子的？
我个人认为，电解槽的规格，就是系列电流的大小，对于涂层材料展示出它的使用效果，没有影响，因为我们统一，不管是海德鲁、美铝、皮质链或者中国的电解铝企业，我们都是使用的霍埃鲁特电解的工艺，都是使用的相同的电解质体系，都是使用的碳阳极作为，碳材料作为阳极。那么在中国，我们在300、400、500千安的电解槽上面均取得了成功，而且都有规模化推广的案例。
Okay. So Mr. Wang said electrolyte cell capacity does not affect the performance of the coating material, no matter it's like a 240 or 300 or 400. And it doesn't make sense. There's no effect at all because we all adopt the whole Herald process.
The whole Herald process. Okay. So what are the typical costs for coating relative to traditional anode production?
Actually, I would like to answer this question. The cost part is depending on the locations and all because it includes both the material and application part. So on a specific inquiry, Mr. Uni7 and Babel team can work on the cost part and share with the team. And just to reply to Mr. Leonardo's question on how this coating is applied, it is not applied with paint brush or something. It is a special application process. It is applied with spray gun on the anode surface after the rodding operation is done. As Ms. Julie explains to you, it is applied on normal temperature. No heating is required. It is applied on the anode surface. Because of the property of the material, it quickly dries on the anode surface, and you need to rest it for some hours depending on the ambient temperature, which Ms. Julie explained, that in a hot environment, it can be cured faster, but in cold environments where the temperature is sub-zero, you may need to wait for 10 to 12 hours before putting the anode into the pot operation. So when the anode is put into pot operation, the anode surfaces touches the bar and the high temperature inside the smelter, and it creates the sintered structure around the anode, which helps the carbon reduction.
Thank you so much, Mr. Ghosh. Julie, I would like to go on with the last question for today. That is, how is the coating applied in practice? That is on-site versus pre-coated by suppliers.
I just answered the question. I think I just answered the question how the coating is applied.
Okay.
So that is the question was.
Well, the coating, 博彦
You can add.
他想问那个是怎么涂的，
我们现在基本上都是在这个阳极组装的现场实施的。一般来说，就是在 阳极钢爪与碳块的组装过程后实施。那么尝试，如果说是让这种供应商来实施，这也是一个不错的办法。但是如果说让供应商来实施的话，需要解决阳极在转运过程中的碰撞及夹击损伤的问题。那么再有一个就是我们在组装可以采用2种喷涂方式，一个是人工，第二个是用机器人来干。
Okay, so currently our coating is mostly applied on site, and typically after and we do manually, and also some of them now we also have robotics. And yeah, our robotics, especially we soon gonna do in Pingo smelter. Yeah, we have robotics, and like what you said, another way to do it before we supplier apply coating. This is might be also a option, but the only thing is we need to consider about the collision damage or fixture damage, the coated anodes during the handling and transportation. As this is, feasible, this is fine. Yeah.
Okay. There's one question in the chat box that I can see. I would ask Mr. Ghosh if he has already answered this. Like, what is about the cleaning of the remaining material on the top of the butts? But is it easy to clean by short blast?
Yeah, by water. Yeah.
Okay.
Julie has already explained. Miss Julie has already explained that this
Okay.
can be washed with water
Yeah.
on the used bath surface, from the used bath surface.
Yeah, because our coating is inorganic, can be washed by
Yes.
water.
So with that, we are about to end today's webinar. I would extend my warm thanks to Ms. Julie, Mr. Wong, the UNI7 team to collaborate with us for the webinar. Thank you so much, Julie, for being a part of this. Also to the people who have made their time and showed up. Thank you so much.
Welcome. Such a pleasure.
谢谢 ，Thank you。
Thank you.
See you. Thank you.